Okay, so we don't have big agenda for today's presentation, so we are going to take a closer look at one of the new capabilities in our platform, which is natural language processing, also implemented as an extension, so that should give you some ideas about how the platform could be extended. And then if we have time and interest, we can touch base on the advanced filtering that was recently implemented in the platform. So having said that, let's jump to our first topic, which is natural language processing. I'm passing the stage to Dan Skatov. And then you are the host now.
Thank you. Do you already see my screen? I guess you do. Could you please confirm?
I see presentation, user meeting 8.
Oh, okay, I see. Yeah, now just a second. And now it should be it.
Yes.
Yeah.
Very good. Okay, thank you. Good morning and good day to everyone. So today, we're going to talk about our recent developments in a relatively new area, which is processing natural language, namely unstructured texts of any nature. And the topic is really broad. And actually, you deal with natural language processing every day when you use search systems, for example, Google. However, today we're going to expand our view, not just thinking of the internet texts, but rather of unstructured textual data of any kind. You can grab from internet, either from internet or from your internal sources. Some data you can produce internally in the organization. For instance, in large organizations, there used to be reports produced for many operations, and these reports can later be used to glean new insights from the text. So what you want to do with unstructured text is that you want to take this raw text and extract information from it. When I say information, I mean something that is structured, something that has some semantic meaning, something that you can use later in the data processing pipelines, something that derives, or helps navigate new information for you. And this is the topic of today's meeting. We have recently worked on our NLP package, which is publicly available on our GitHub. For those who are interested to have a look at these developments, you can go to datagrok-ai/public and go to NLP package. And there's going to be the latest version of it I'm showing to you. And actually, I'm not going to show this on the developer server just yet, since I wanted to show the latest stage of it, and I haven't deployed that yet. So what I'm going to use instead, and I encourage you to do the same, is that I'm going to use our Docker image through Docker Compose command. And it's actually pretty simple to do. I'm not going to repeat that now, but it just took me several minutes to fully deploy Datagrok in an image on my computer, and that's what I'm currently running for this demo. So the only thing you have to do is that you have to go to that link and take this Docker definition file. Then you should put it in a separate folder, actually anywhere that is useful for you. And then in that folder, once you put this file with that content here, you run that command, Docker Compose up. And then in a few minutes, you have fully available, ready to use Datagrok instance on your local computer. If you shut down this image and start it back again, it will preserve the state, so you don't need to redo your things. I really encourage you to use that way of trying out and working with Datagrok. Let's proceed to the NLP demo. And I have to note here that the topic is really broad and we just started with that functionality. However, already what we have today is quite interesting and can be leveraged in daily work of your organizations while working on the data that includes natural language. Okay, and let me start with some really useful functionality we have in Datagrok, and that is our file browser. And this is something you might be already using a lot. However, I find it's important to emphasize that this functionality is always available. It turns out that not everyone has been using it. So what I have here is actually the bare bones empty instance of Datagrok that has no demo files as compared to developer's version. And in this file browser, you can see, for instance, the file shares that you can connect to inside your local network. And you could do this, for instance, in here when you add a new connection and you choose the files as a data source, and then you have to provide your share location name in here, and if necessary, login and password, and then it's going to be up and running in here. However, I'm not going to do this way. I'm going to show you the other way instead. And I have prepared a bunch of files to show you the NLP functionality. I have to admit Nico, excuse me. Yeah, good. Okay, so I'm just gonna do this. And the files are uploaded to Datagrok, and I'm gonna navigate into the files. And actually for some of the files like txt, for instance, you already have the previews available. This is also available for images, though I'm not gonna show you the image demo today, but it's a subject for next meetings. However, for some of the files, we already have the preview. It's going to expand in the future. We don't actually preview PDFs and doc files today, but that will come as well. And you can easily manage files and download them and do other things that you are used to doing with files. So let me now proceed to the first file for the demo. If you have no questions as of now. Okay, so I'm going to use that file with reviews of drugs that was fetched from a resource called WebMD. I can actually show you the exact origin of that file. This is the WebMD data fetched for one of the Kaggle competitions. So it's in a publicly available file. You can also try out yourself. We're going to make this file as part of the demo files on developer server and the later public server of Datagrok. So let's oversee what this file contains. We have the name of the drug. This will be of our interest. Then we have an age of the person who made a review in a free text form for the drug on the WebMD website. We have the person's sex. We have some other data that we're not going to actually use in that demo today. And we have some labels that the user attached to his or her review. So this text actually contains a lot of information useful for further analysis of that data set. And this data set is not very big right now. It's about 3,000 rows, something like that. And what I'm going to show now is a typical data augmentation process for the data that you receive originally. You see that there is some useful things you can do with it, and you augment that data with some additional columns, so to say, that contain certain features for the information presented in the rows. And then with that augmented representation of the file, you can do further analysis. For instance, you could do predictive analysis. We're actually gonna show this today as well, based on the augmented data set. However, let me proceed to the NLP process here. So in the package, we made one function available in the ML section of the menu, and it's called sentiment analysis. Okay, so we have to choose the column for the analysis, which is going to be reviews. And let's just make the script run. And while the script is running, I'm going to tell you about the technology that we employ in the NLP package. So in that case, the technology that we use are the ecosystems of R and Python packages available in their ecosystems. I'm just going to show you a list of some of the packages that we are using right now in the NLP package. For instance, this is the package for text extraction. This is the package for cleaning text, and some other popular NLP packages, etc. And our point here is that we're not really gonna produce some stunning new methods for NLP. Rather, we're gonna find and make available the best of the best methods, facilities and packages in the ecosystems through Datagrok. Yeah, and it is still running here. And this runs using our compute server that provides for running R and Python scripts on Datagrok platform. And these scripts come as part of our package. And actually, this example here is just that we made one of the scripts written in R available through the menu item in Datagrok. And we expanded the interface with that menu item. And there's going to be more. Yeah, it actually is over. And now we're going to see the two new columns in that dataset, which correspond to the polarity of the review and the emotion that is embodied in that review. I will admit add to join. Okay, let's have a closer look at the data in that two columns through the exploratory data analysis capabilities, Datagrok. So first of all, I'm going to see what we have in the emotion column here. And as you can see, we have actually 7 classes of emotions, and one of them is unknown. So as far as you can see, about 1/3 are unknowns, but still 2/3 contain some useful data. And of course, we can start with some very simple visualizations over here. For example, you can really just check, for instance, how the emotions are distributed as an outcome of that data augmentation process. And it's actually fun to see that a lot of joy has been attached to the drug reviews, but that might make actually sense because in the end of the day, the drug should make the person feel better. However, what I'm going to be interested now is some closer look at the data we have over here. I can actually explore it in various ways in here, but let me proceed to more advanced functionality. So I want to really see how the data in that file correspond to one another. And I'm going to use for this something that is called and here, yes, something called stochastic proximity embedding. And this is an interesting method that allows you to visually analyze the data set based on the likeliness or proximity of the items in the data set to one another. And since we can only perceive information with our eyes in 2 dimensions or 3 dimensions, what you want to do is that you want to take highly dimensional data and you want to project that data into lower dimensional space. In that case, it is 2 dimensions or 3 dimensions, okay? So let me see what can I do with the available data. And I will be interested in taking into account some data that is non-textual in that data set, and some data that we augmented the data set with. However, I cannot do it directly because there are some nulls in the columns, some of the values of the columns that I want to fill with some meaningful values. So let me do that first. And for that to be done, I'm gonna select the missing values imputation functionality, and I'm gonna actually impute these columns, values in that columns that has nulls, okay? So I'm gonna select those, and then I'm gonna select also the data that I base my analysis upon. And I'm gonna select some categorical or numerical columns in my data set that do not have nulls. And yeah, I think that's enough. And let's run and see if that helps. No, Docker is not what I intended to see over here. I'm sorry for that. Okay, so we actually succeeded to complement the null values, missing values for some of the columns, but not for all of them. Let's repeat that for other missing values based on some other data set selection. I'm gonna impute this. I'm gonna base that on, we put it the agent sex, let's say. And then I can go back to stochastic proximity embedding dialog. And now we have succeeded with the process. And we can actually perform the desired analysis. In that analysis, our augmented columns will actually make a sense, and we're gonna see it just in a few seconds. So for the proximity embedding, I'm gonna select several columns such as the age, sex, the numerical categorical values, ease of use, satisfaction, effectiveness, useful count, and then the emotion and polarity that we have actually produced to that data set. And then I'm gonna produce the very interesting plot. We could also do this in 3 dimensions, but as of now, let me keep it in 2 dimensions.
So you did the imputation of missing values on the previous step.
Yes, I had.
Right. I just wanted to mention that we are currently working on a much more advanced version of that process, where the user will be actually guided through each of the steps with the explanations of what's happening, what are the best methods for imputing missing values in that particular case. You'll be able to specify the reasons for why they're missing, and we also support about 15 different state-of-the-art methods for missing values imputation. So it's coming for the next presentation.
Yes, thank you, Andrew. Think of this imputation demo as the prolegomena to the next great demonstration. This impute package that Alex is working on is really advanced and is really good. Okay, but now the embedding has done computing, and we have 2 new columns augmented to the data set, and these are the actual embedding space and the coordinates in that embedding space that have been produced. Let's visualize that. Yeah. Okay, let me think what we actually produced over here. So yeah, it seems like in the data set, there is actually no structure that is particularly interesting for clustering of the data. However, in some of my previous runs, I managed to get some more interesting results on the subset of the data. But unfortunately, I couldn't reproduce that as of now, the current run of proximity embedding. However, in the result, you can actually see that there is some kind of a separation space in between of the data points, and there are some outliers you might also be interested to explore. And you can navigate the space as follows. For instance, you can look at the polarity produced.
Dan, sorry, maybe it will be the good idea to set the color to the polarity.
Yes, would be a very good idea. Let's do that.
On the scatter plot.
On the scatter plot. On the, yeah, that's it.
Exactly. Let's try that.
It would also be a good idea
yeah.
to convert the drug names to the actual chemical structures.
Yeah.
See them on a tooltip. It's possible. I don't know if you can do it on such a short
Maybe
right now.
Maybe try to switch color to emotion. I think
we can try that too. That's a very good suggestion. Yes, and actually you start to see some kind of structure in the data set. I have to say that I was working with some of the subsets of the drugs, and we will try that too. But in the subset, there was a very interesting layering of that embeddings based on the emotion. However, in here, we can kind of see the structure coming up as well. And yeah, so the emotion that is green actually became a joy, which is kind of nice. And the red emotion is sadness. And you can navigate the data space further by clicking on the points in the scatter plot and analyze the data. However, I would like to proceed with some filtering functionality right now. And I'm sorry, Andrew, if I will steal some part of your demo in the second part, but this really makes sense to do it over here. So what I'm going to do is that I'm going to take a couple of drugs that has to do with same type of diseases. I think they have to do with the pain, and I'm going to just use the filter to sub-select these and navigate in that subspace of drugs with emotionality coloring. So yeah, let me add a column filter that that relates to drug. And navigate to it. And what I'm gonna do now is that I'm gonna just select some of the drugs I'm interested in. And I'm gonna select the drug called Lyrica. And the other one is called Tramadol. I have to confess, I had to Google for it. Never had any experience with such drugs. However, I found that they are typically compared. So now I can see what happens with the sentiments that only pertain to these two drugs. Okay, and I'm gonna go to the bar chart again, and I'm gonna do is that I'm gonna compare the emotion that is related to either of the drug. So now I'm doing this for, let me just verify. I'm doing this for Tramadol, okay? And so as you can see, this one has actually in total has quite a lot of reviews, and not too few of them are positive. There are some anger and disgust, but many are about joy. However, I'm going to proceed to Lyrica, and oh, yeah, sorry, I have to deselect this. Yes, now it's correct. Okay, so now I have the 3 items in the filter, right? And now, actually, this filter correlates to Tramadol only. Okay, so this is the Tramadol result. Then I'm going to switch over to Lyrica result. Okay, quite a bit fewer reviews for Lyrica, and not a lot of joy for it. And it might have to do with the fact that there are just fewer reviews for Lyrica, or it might have to do something with the properties of these drugs. And you could further analyze the data by looking at the ages of the reviewers and stuff like that. However, what I'm going to try out now is one more interesting functionality of Datagrok, which is predictive modeling. What I'm going to do is that I just close that first and the rest of the filter. What I'm going to do is that I'm going to predict the column called effectiveness based on the other columns available in the augmented dataset. Therefore, I'm going to take the ease of use, satisfaction, useful count, emotion, or actually polarity, just polarity for the sake of demo. And I'm going to produce the prediction for effectiveness. Let's do that. So let's go to data science and select, actually let's go to predictive modeling and select train model. And I need to do what I just said. I have to predict the effectiveness of the drug based on a number of features. Maybe we should include this too and see what happens.
Do we have
and,
any?
Yeah, am I going?
Do we have any NLP specific models? Sorry for interruption.
No, we don't have any NLP specific models in that area of functionality. I'm going to talk about this later in the presentation in order to explain how it's going to work in the future. Since for this functionality, you have to produce embeddings for the actual text, and we don't do that yet. However, I'm going to use the polarity produced in the dataset. And this is using the model engine called H2O. This is a popular open source technology that we run on our Datagrok server, or currently is actually run on my local computer in the virtual machine. And in this setting, all the choices is going to be made automatically for you. Okay, so I just selected the column I'm going to predict and the features the prediction is based upon. And I'm going to run this with default setting and see what comes. After I train the model, I'm going to take another smaller subset of the data to see how well the prediction works. And I was trying a lot of these models on our data sets for NLP demos in order to understand what can be derived as a valuable output. And one question I'm going to post right through the presentation to my colleagues is about the type of the column in the modeling engine. So to say, we have some columns which have numbers in them, but really what they are is actually categorical values. And I don't think that H2O can handle this in the desired way. However, let's first come to the end of the simulation, and end of the training, sorry.
Yeah, what would be really good to do in the future is to connect our functions, which would be written in any language, with the predictive engine, so that the engine at this point would understand that we can derive things like polarity, emotion, and so on from the unstructured text. And then the end user will not have to know all of that in advance, but instead, during the training of the model, we will automatically offer the feature that could be calculated automatically based on a column. If you know what I mean. That would take it to the next level, because then the end users would not have to know in advance how it can be built, right?
Absolutely. Absolutely. Speculative offer of the things that you can predict is very valuable, and we're going to definitely add that, as well as the sort of automated derivation of the embedding for the text. We're going to talk a little bit about that also today. Okay, but now the training is over, and let's see if any valuable result comes out. Let's go back to our drug reviews. And first, let's apply the resulted model basically to our existing data set. And as we specified, we want to predict effectiveness. Okay, now we're gonna apply the model. And there's just one model I have, since it's a bare bone setup of Datagrok. And yeah, let's apply it. See what comes out. Okay, so what we got over here is actually maybe not quite what you have expected, since you definitely interpret the effectiveness as a categorical column, right? But the H2O engine treats it as the numerical column, and I couldn't alleviate that by setting the type of effectiveness column to string. So maybe my colleagues could guide me in that, or maybe this is something we have to adjust to the H2O itself. However, if we actually compare these two, we're going to see some correlation, actually quite a good correlation between these values. For instance, here we have 3, but the predicted value is 3.65. For the 5, we have 4.89. However, not all of them are good enough, 5 and 1.75. But I would say that most of them in the training data set are good. However, let's apply the same model to our test data set. Now I'm going to go back to the file browser and select a smaller set for the test, the set where we have not seen that have not been seen in the training process. First, I have to run the sentiment analysis on the data set as well to get the desired columns. And this is going to be based on reviews. Okay, it should be fast. Exactly. And now I'm going to go to predictive modeling and apply the model. And as you can see, the model becomes available for that data set. If there have not been enough columns in the data set for a certain model, it will not pop up, but we have all good and it's good to go.
Yeah, for the next demo, we should connect all the dots, I think, and do everything speculatively behind the curtain, sort of. So when you click on a text cell that contains a review, which will also be determined automatically that it contains a drug review, on the side panel, you will see the prediction for its effectiveness.
Yes.
Mm-hmm.
Yeah, totally agree. It's like you may want to use numerous ways for that. Either you could augment the data set, maybe save it for some later use, or you could see it right in place, or actually combine both. Both of these are very useful. Okay, but I've actually applied the model to that test data set, and as far as you can see, the results are quite interesting. For instance, in here, the effectiveness is 3, but the prediction is 3.72. And this is 1 and 1.75 and 5 and 4.69. So it actually makes sense. And what was nice about this, it just took me 4 or 5 minutes to produce this result out of the augmented data set. I think that's really powerful.
Can you compare,
okay.
I'm sorry, just one thing. Can you just quickly visually open the scatter plot of predicted versus real?
Oh yeah, that's a very good suggestion. Thank you, Andrew.
Yeah, oftentimes it's possible to spot classes of that for some reason fail to predict properly, and that really gives you a lot of insights.
Yeah, the confusion metrics of a kind.
Mm-hmm.
Yes, so as far as you can see, quite a few of them are actually positive outcomes. So it's kind of biased data set in that regards. However, if you look to the others, they tend to be closer to the diagonal as far as you can see. So it's actually makes sense even without tuning, I think.
Mm-hmm. Okay, thanks. Yeah, probably. Yeah. Would be good to
you have to balance the data set.
language processing, right?
Yes, exactly. Yes, so now comes the Next topic, which is content extraction and conversion. As we move forward, let me go back to the file browser. Okay, so first I'm going to show you some relatively simple things that we can do with simple texts. This is just a TXT file on disk and now in the Datagrok. And I want to show you a very simple panel, yet a useful one, which is called text statistics. So what this panel currently does is that it identifies the language of the text. It counts some very simple statistics, words and sentences, and it applies the readability score test based on the detected language, since there are different readability scores metrics for different languages. And this is a very simple instance of a panel, yet it is actually quite useful. But let me proceed to some more sophisticated example, which is the PDF file. Okay, and let me close that one and show you the functionality for text extraction.
By the way,
there is another panel.
Programmatically, the statistics method, or does it have to be executed against the file?
Diana, could you please help me with the answer?
You can probably look at the actual script of the panel to see what's happening there.
It works on the file.
Yes, so as far as I understand, the input to that function, let's open it. Let's go a little bit more into the code. That was the summary panel, okay? And I'm gonna go to the source and look at the summary panel.
I think summaries in scripts.
Oh yeah, it's in one of the scripts.
Yeah, you can actually click on the eye icon right on the panel to see what's happening.
True. True.
Yeah, click on it. Yes.
Yeah, and this is the script. Yeah, that was faster. Yeah, that's a good proof that you have a lot of useful things in Datagrok available. Yeah, so the input is based on the file type because the you mean sorry, it's the summary, but we are interested in text statistics. Let's check that. And the output are just values that you can call from any of your other scripts.
Mm-hmm. I see. Yeah, I remember we planned to make it transparent so that it would work on either arbitrary texts or files with implicit conversion, but looks like we'll demo it for the next time.
Yes, and just a little note about that. Indeed, it is the plan to have converters that will identify what can be converted into what, and then the pipeline shall be built around that possible conversion. Therefore, we don't really need to process different types of files as we do right now in the package. So to say, we have to see that we actually first call the text extraction module, if that's a PDF file, for instance, and then we pass it over to the translation engine. However, that will soon come, and things will get more orthogonalized, so to say, more kind of fine-grained, and you can compose them better. Yeah, thanks, Andrew, for the navigation here. And let me go back to the file browser again. Yeah, what I was going to show is the extraction of the text. This is actually a research paper about coronavirus written in French. I'll just show you the file itself. Yeah, and using one of the NLP modules from Python, we can easily extract the raw text from that file. And this raw text is important for further processing of these files, for not only for statistics calculation, but also for translation that I'm going to show very soon. Okay, so now we're going to proceed to yet another interesting information extraction method that is working with the cloud. Actually, in our NLP package, we leverage AWS NLP-related cloud functionality a lot. And I will just point you to a couple of links. One is Amazon Translate. This is the cloud service that we will demo today through Datagrok. And the other one, which is very interested in medical applications specifically, not just for text in general, but there is a set of NLP methods called Amazon Comprehend, and there is a lot of features in it. You can do sentiment analysis in the cloud. You can extract key phrases and many other things. But what we are focusing on is something related to medical applications, which is really in advanced state for the Amazon Comprehend. So I'm just going to show you one instance of Amazon Comprehend Medical. This is a very technical showcase, but it can give you understanding of how rich the information can be, how rich it is extracted. So I think this is a panel called Entities, and it works for the text files. For this one, it's going to be quite interesting. Okay, so now what happens is that we actually pass that text to our account at AWS and return you the result. And there is a lot of medical entities information in it. For instance, there are procedure names, there are drug names that are extracted as a structure. I just scroll through that for you to give overall understanding. And so the question might be, what we want to do with that? And the answer belongs to one of our previous presentations where Alexander showed our indexing and search system capabilities and the attributes of files. Basically, what is really interesting to do is to extract this various semantic tagging information from the files, especially using Amazon Comprehend, and put them into the index so that later you could search in the files using that index. And this is a really powerful use case, one use case where you just work and manage your files. But another case is definitely a feature extraction for the files, where you can use that features that are stored in the attributes in the index to cluster documents, for example. And this is also something we're going to work on and show you at one of our next user meetings. But the source of the power is in this really fundamental cloud functionality that we employ.
So
okay.
essentially we'll be easily able to point to a folder containing thousands of unstructured texts in any format and then classify it, right, by different metrics. And not only classify it, but also find occurrences of, for instance, specific drugs or classes of drugs or conditions and so on. Yeah, that's
yes.
really interesting. You know what we should do for the next demo? Extract names of drugs into our indexing engine and then search through it using substructure search, chemical substructure search.
Yes, yes.
It might not make a lot of sense from the research perspective, but it will be definitely a very interesting demo.
Yeah, this is the convergence with the big C. It's definitely so that we want to cross-pollinate the different areas of computer science, and that's one really good example.
Mm-hmm. Mm-hmm. All right. Do you see my screen with Datagrok on it?
Yes.
Okay, thank you. So let's open one of my favorite demo files. So what I will be showing in the next, hopefully 10-15 minutes is the new filtering functionality that we have recently completely redesigned. So they do look quite similar to what you are used to, but internally they work differently, and the aesthetics are a lot better now, and also the UI and UX has been completely revamped. So yeah, in our opinion, it's a lot more clean and intuitive right now. So these are the filters that I just opened by clicking on the filter icon. And it allows for really quick filtering, selection, and profiling of the contents of your dataset. As you can see, by default, it created these small filters for all columns that we have in our dataset. If in cases if there are thousands or even millions of columns, which is possible in our platform, of course, we'll see a smaller subset. I think by default, it limits it to 20 or 50, but this can always be changed by clicking on select columns and selecting exactly the columns that you want to see based on either data type or name or number of empty values or other tags. So once the filters are open, they remain highly interactive. Actually, let me open a couple of more viewers just to demonstrate what will happen with filters. So by default, they simply show the content of the columns with some information, so they do not filter anything out. And there are, you can do certain things with this, such as, for instance, just hovering over a category will highlight the records belonging to it on all of the viewers, which is really convenient. Also, not only it highlights the records on the viewers, it also highlights the different distributions on numerical values and so on. So just hovering over different diseases, we immediately see how the distributions differ. And so far, I have not made a single click. I'm just hovering the mouse. But of course, they are filters, and their main purpose is to filter data. This is done using the checkbox on the left. By default, they are all checked and they are all grayed out in order to not distract you, because since they are not really filtering, it's not important. But once we do start filtering, for instance, I want to uncheck anything, they turn bluish, so you know exactly what's being filtered. And there are several ways to figure out what's currently filtered. First of all, the blue checkboxes, and then the indicator on top of the column that there are 4 categories currently allowed to go through, others are filtered out. By the way, when you see that indicator, right click on it or click on it, and there are actions where you can easily select, deselect, or invert all. It applies to other indicators as well. We'll get to it later. And the third way to figure out what's being filtered is as soon as you change the filter, you see the number of filtered rows along with the description what's being filtered in the property panel. We are also thinking about introducing some indicator on top of the platform, but it should be really lightweight and elegant. It's coming soon. What else can we do with filters? Oh, first of all, we can, if we are only interested in this column, we can we'll click on the number of filters. This indicator shows the number of filters currently active, and remove others. So I'm not gonna do it, but in this case, only the, let's do it, the default will be showing. Yeah, by the way, please interrupt me with questions. Are there any questions so far? Okay, I'll proceed further then. And let's take a look at the different options for all the viewers. First of all, it's really easy now to turn filters on or off. And when you toggle it, it still remembers your options. That's just a temporary toggle. Similarly, you can disable and enable each filter individually by clicking on the same icon. Then it's easy to expand or collapse everything. So you can see an overview of what's happening and reset the filters. I'm not going to do that, but essentially all the conditions will be reset. Lastly, a convenient thing to do is to search filters, which is really handy when you have hundreds or thousands of them. So we can search for name right now, and we plan to introduce more categories of search. So for instance, we can automatically leave numerical columns or columns having certain tag or so on. There will be both a free text search, which is increasingly useful, and advanced search where you'll be able to specify exactly how you want it to filter. Okay, and then there are certain options and controls on each viewer as well. As you noticed, the controls only appear when the mouse is moved inside the block. So by default, everything looks clean and you are not overloaded with additional information. But once you need to control something, just move your mouse. Of course, we can sort by anything. I've just pressed escape, by the way. When you hit escape, it resets all the filters to their initial positions. Then when you sort by something, you see the indicator going down, meaning that it's in the descending order. That also means that's supposed to show the user that you can actually sort not going through the icon, but by clicking on the invisible header on top of the column. So the same action could be done by doing just like that. And this is exactly the same UI and exactly the same concept as we use, and exactly the same control actually internally as the spreadsheet. That is a central control for data exploration in our platform. And you would also sort by double clicking on the header. So all the things apply. And of course, it's convenient because it's visual and you can simply point to a column and sort by it. It would work with numbers, categories, and checked conditions as well. Next control is searching for categories within the filter. Dan has already used it in his demo, so it works as expected. You can also close it. Another convenient thing is that when you need to select just one category, you don't have to uncheck everything like that. Another way to do it is to click not on a checkbox, but on a text on the category itself. In this case, it will be filtered exclusively. So I can go like that and click categories exclusively. So for instance, if I'm looking for females, Caucasian with indigestion issues, it's 3 clicks. It's also very convenient sometimes to use the keyboard to go through each category. And in this case, I'm hitting up and down. And you can see we are filtering it interactively. It's also one of the biggest changes between this version and the previous filters is that you see that background. So now previously it used to reflect total numbers of rows that fall into this category. Now it reflects relative numbers of the rows that pass filters. So if we are to filter on any column, we'll see everything updated interactively and dynamically. So it's a really convenient way to do exploratory data analysis. So pretty much you don't have to open many viewers. We can still do that, but currently there is no reason to. In many cases, this information is more than enough. And the numbers of rows that pass filters are also updated interactively. So you can see exactly how many rows are there. All of that could be also controlled. I mean, all of the visual representations from the settings of the filter. To edit filter settings, use the gear icon, the same as you would do for any other viewers. And you'll see plenty of settings that is related to filters. So if you want to customize it, we expose different options here. By default, we tried to make them look really clean and efficient. But for instance, you can do things like always show certain input boxes and so on. Speaking about the input boxes, another addition that we've made is that our numerical filters could also be set explicitly by using this button. And the values could be entered in these text boxes, so you don't have to use the slider always, which is convenient, of course, if you need to specify certain values. Also, what has been missing previously is the ability to decide whether or not empty values should be filtered out. So this checkbox currently controls it. By default, as I mentioned earlier, we do not filter anything out. So all the settings are set to allow passing everything. But so if it's checked, it means that nulls are not coming through the filter. Lastly, the same control can be used for selecting the data. And to do that, we can use the column on the right that contains numbers. It works in exactly the same way as any other viewers. So let me show you an example of what I mean. So here's the bar chart, and to select stuff exclusively for that category, you see I would simply click on it. And the rows are selected, and the rest gets deselected. To toggle the selected state, we would press Control click, so it would deselect the same region. To add to the selection, we would do Shift click. To toggle the selection, or to deselect corresponding rows, we would do Control Shift click. Well, I agree it might be not the most intuitive things, but we need to do 4 actions from the keyboard, and we only have so many modifier keys. So, and the same, by the way, please note that the selected rows are also indicated on the filters. So we see exactly how people with psoriasis, what the distribution of ages and weights and heights compared to the rest of the population. And exactly the same keyboard shortcuts would work with on these numbers. So for instance, if I want to select race equal Asian, I would simply click on it and they are selected exclusively, meaning the rest are deselected. If I want to toggle the selection, I would click with holding Control, and the same stuff I would add to the selection with Shift. So this is, while it looks very simplistic, this is a really, really powerful control for exploratory data analysis. So personally, when I deal with the data sets that are unfamiliar to me, this is definitely the tool that I use at first, just to get a feeling of what's in the data set and be able to profile data and ask questions in a really interactive way. I will also mention that we've recently added a capability to implement different filters externally as plugins in JavaScript. So here are two of the filters that we are currently working on. They are not completely done, so I will not do the demo, but for instance, we can do a search by substructure, chemical substructure using this filter, and behind the curtains it will load an external package and execute the code and do all sorts of binding. So it's not these viewers come from the core, but it's also possible to create completely different viewers that would still play nicely with this whole concept. I'll just show a tiny little demo. So if we want to do some chemical filtering, so we would put a cursor on a column with molecules and press Ctrl F. And now we have this substructure filter coming from the plugin that is part of the filter group and adheres to the same constraints and UI capabilities. And as you can see, it's completely looks like our development server is down. It's completely different UI, but it will play along with the regular filters as well. All right, I think that's pretty much everything I wanted to show on filters. I might have missed something, and I know we have a few people on the call who are really, really interested in having this functionality streamlined. So please, any questions? All right, if there are no questions, then are you ready to get the control?
Yes, I am. Thank you, Andrew.
Okay, great. I'm trying to pass the control to you now. And you are the host.
Thank you. And my screen is on. Yes, I fixed my mess here, and the dessert often comes in the end of the meal, so does the translation panel. So let's proceed directly to the demonstration here. I select the German text, and I open the translation panel. And here we go. So let me just show the original text. This is the file, which is a quite image-rich, design-rich PDF file in German. But we actually extract the textual data from it, clean it, and then get the translation. In fact, the translation that we derive here is just a snippet from the beginning of the file. because I mean, if you have a large file, you will have to wait a little before the translation of that file comes back from Amazon. Therefore, what you want to do first is to get the overall idea of the file content, and only then, if you see it's worth translating further, you could do that. We don't provide for it yet, but we're going to do that in the next release. There's going to be a button provided or something like an input element where you could choose to translate the whole file and get it back, presumably also as a file. But right now, it's also very useful to get this translation. Actually, one more application of the translation is to take it to the further step, which is the summarization of the text. That's another panel that I didn't show you in the first part. And basically, the summary of the text is a short extract of the most meaningful, information-rich sentences from the text. And there are two kinds of summarization, which is called an extractive summarization and abstractive summarization of the text. In that instance, we see an extractive summarization. So to say, the summary is formed by the exact substrings, subparts of the text. However, in the abstractive summarization, the actual abstract for which we could also specify the desired length is formed as a new text. That is, it does not necessarily contain any of the existing subparts of the original text, but it's like a rephrase of the text in a natural language. And this is very powerful, and these both is something they're going to work on in the future versions of the package. Okay, then, so you could see also that the language for translation has been detected automatically. And this is what we have seen already in the text statistics panel, where you have seen the language detected. And then the English is the default choice, but you could choose some other languages. And the same works for all the popular document formats, which are PDF, doc, for instance. Let's try docx. Yeah, there should be something still with my setup, but oh yeah, actually, I know what happens. Yeah, this is yet another thing that right now we're using the free tier of the translation engine, and at some point when I start to do this too fast, it throttles me. However, you have seen the functionality already. The throttling will not be an issue once we deploy it publicly. However, it currently is an issue for me. So can actually could fix that by connecting to a VPN. However, I'm not going to do this right now. Okay, then. So thank you for listening. I hope you enjoyed the different means for analyzing unstructured text. Maybe the last thing I'm going to add about the sort of the holy grail of text processing as of today. This is called word embedding, or embedding in general. So what it is about, this is a process where you take raw text. It can either be a sentence or a whole text, and you convert that textual entity into some kind of a numeric space of certain dimension where the similar or related entities from text correspond to the points that are close to one another, right? So this is called embeddings, and this is already something we have seen with the proximity embedding plot. However, the same technique can and should be applied to the text, raw text, and the features that are produced can later be used in a more regular, well-known ML pipelines. And this is also something we're going to support. This is a really new technology. I mean, the commercial applications of it. This is something started in 2014 when the revolution in NLP has happened with the new approach that instead of conventional statistics and rule-based systems, people started to use the approach based on embeddings, and that became possible to efficiently compute using GPUs and cloud computing, and then it became the whole new thing, and it's very powerful. And this is also something that you're gonna see in the next releases of our package. Therefore, thank you for your attention. I will pass the stage back to Andrew.
Thanks a lot, Dan, for your presentation, and thank you, Diana, for your work on the NLP package. It's already impressive, and I can see so many ways where we can evolve it further. It's really just the beginning of it. So I think we are almost at the end of our presentation, and we don't have any other topics for today, so it would be a good idea to give the rest of the time back to the participants. Again, thank you all for coming. Please see us in 3 weeks, and we'll distribute the agenda before the meeting. Thanks, everyone. Bye.
Thank you. Bye-bye.
Thank you, Andrew. Thank you, Dan.
Thanks, Andrew. Thanks, Dan.
Thank you.